Hi all, welcome back. Today we are going to learn a new topic, that is Hermitian Matrix. Our topic is Hermitian Matrix. First, let's learn the theory. After that, let's do problem. Our topic is Hermitian Matrix. Hermitian Matrix, which is a important topic and question for all kind of physics and mathematics competitive level exam. So our topic is Hermitian matrix. Let us consider a matrix A is equal to 1 I, imaginary part I, then minus I 1. This matrix A is equal to 1I minus I 1 is said to be Hermitian only if the value of this matrix A is equal to AH. This is the condition. Suppose the matrix A is said to be Hermitian if, what's the condition? The value of this matrix must equal to AH. This is the condition. Then what is AH? What is AH? AH is conjugate. AH is conjugate transpose. AH is the conjugate transpose of this vector A. AH is the conjugate transpose of this vector A. So what's the condition? That a matrix to be Hermitian, that matrix is equal to AH. AH is conjugate transpose. This is the basic theory behind Hermitian matrix. Okay, this is all about theory. So let's do a problem. So let's do our first problem. In our first problem, a matrix. In our first problem, a matrix A is given as A is equal to 2, 1 minus I, 1 plus I, 3, 1 plus I, 3. This is the matrix given. We want to check whether this matrix is Hermitian or not. We want to check whether this matrix is Hermitian or not. We want to check this matrix is Hermitian or not. So what's the condition for that matrix want to be Hermitian? What's the condition? This matrix A should be equal to AH. What is AH? AH is conjugate transpose. A is conjugate transpose of matrix A. Okay, this is the condition for that matrix to be Hermitian. So first let's find out the conjugate of this matrix, then we can find out the transpose. then the conjugate transpose matrix is equal to the matrix A, then we can say that the matrix A is Hermitian. So first let's find out the conjugate matrix. How can we find out the how can we find out the conjugate of matrix A? How can we find out? 2 is 2, 2, 3, okay, 3, 1 minus I and 1 plus I, which is equal to a complex number, like in the form A plus IB, 1 minus I and 1 plus I contains a complex part. So we want to take the opposite side. So 1 minus I can be taken as 1 plus I, because I is part of complex relation. So 1 plus I is taking opposite side, 1 minus I. So this is the matrix A. We find out the conjugate of matrix A. 2, 3, 1 minus I is 1 plus I. 1 plus I is 1 minus I. This is the conjugate of matrix A. So then we want to find out the transpose. Transpose of this conjugate matrix. Transpose. So from the conjugate matrix, how can we find out the transpose matrix? Do you know how can we find out the transpose matrix? We are going to find out the transpose matrix. This is a column matrix. This column matrix write as row matrix. So 2, 1 minus I. Okay. Next column matrix. This is the next column matrix, 1 plus I, 3. Write these column matrix as row matrix. So we will get 1 plus I, 3. Write this column matrix as row matrix. So 1 plus I, 3. You get the transpose matrix. This is AH. This is AH. So let's check the matrix AH with respect to the matrix A. 2, 1 minus I, 1 plus I, 3. Here the conjugate transpose is also 2, 1 minus I, 1 plus I, 3. So it is clear that the matrix A is equal to AH. A is equal to AH. What is AH? AH is conjugate transpose matrix. So we satisfied this condition. Therefore matrix A is Hermitian. So this is all about this problem. Hi, then let's do our second problem. Now second problem, the matrix. In our second problem, matrix A is given as 0 I minus I 0. Okay. this matrix given, we want to check this matrix is Hermitian or not. We want to check this matrix is Hermitian or not. So what's the condition? What's the condition? This matrix A is equal to AH. This matrix A is equal to AH. Then we can say that the matrix A is Hermitian. Okay, Hermitian. What is AH? AH is conjugate transpose. A is conjugate transpose. So let's check this condition. First, we want to find out the conjugate matrix of A. How can we find out the conjugate matrix? 0, 0. Okay. Then this complex part I can be written as in opposite side. So minus I. Here minus I becomes opposite sign is plus. So I. So this is the conjugate matrix. Then we want to find out the transpose matrix. Transpose of this conjugate matrix. So let's find out the transpose matrix. How can we find out the transpose matrix? How can we find out the transpose matrix? In the conjugate matrix, this is the column matrix. Right? This column matrix has row matrix. Right? This column matrix has row matrix. So 0, I. Then the next column matrix can be written as row matrix. So minus I, 0. This is the conjugate transpose A H. This is the conjugate transpose. This conjugate transpose is equal to the matrix A. So the both the matrix A is equal to 0, I minus I 0. Here the conjugate transpose is also 0, I minus I 0. Both the matrix are same. So we can say that the matrix. So we can say that the matrix A is Hermitian. So we can say that the matrix A is Hermitian. Okay. So this is all about Hermitian matrix. It's a sure topic for all competitive level physics and mathematics exam. So I think this class is very helpful to you. If yes, surely share this video with your friends. So in order to get more videos as notifications, subscribe and click the bell icon. So let's see in our next class with a different topic.